Hello, Mr. and Mr. Ryan, are you right?
Yeah.
Okay, so we are given an array of digits, one single digit, like 2, 1, 3. Okay, let's just take this one, 3 digits. Each number in the array is 1 digit. So the question is that we want to find out all the 3-digit number, okay? And it has to be even, so 3-digit even number.
That's impossible.
You hear me out, okay?
Because
And
you can't get 3-digit unless you count 0, like 2 times 3.
3-digit even number and no leading zeros.
Oh, then it's impossible with
And
those numbers.
also, the numbers could be duplicated in the original arrays. You need to concatenation of the digits. For example, here, I can do 2, 1, 3. Right? This is a 3-digit.
Yeah,
But it's not an even number. But I can do 3, 1, 2.
So, do you just have to order them?
That's right, yes.
Oh.
But it could be many, right? It could be another 0. We need to return all these 3 digits. So 4 numbers, we want to pick
0. All the even numbers.
even number, no leading zeros.
2, 1, 3, 0.
3 digit.
Oh! 1, 3, 0.
1, 3, 0, yes.
3, 1, 2.
3, 1, 2, yes.
1, 3, 1, 3, 2.
1, 3, 2.
3, 1, 0.
2, 3, 0.
Uh-huh. What else?
2, 1, 0. 2, 1, 0.
Mm-hmm.
That it?
Any more?
3, 2, 0.
I think that's it.
And we need to return this in a sorted, right? We need to sort these numbers from the smallest to the
1,
biggest.
3,
1, 3, 0.
1, 3, 2.
Okay, so I'm not going to do write it, but you understand. Yeah? What are your approaches? So I give you a few integers. How do we prove for? And I can.
check.
Oh, I know. 1, 2, 1, 2, 0.
Okay, 1, 2, 0. That's good.
1, 0, 0. 3, 0, 0. 2, 0, 0. 1, 0.
Okay, so there
two.
will be many. So what's your source? So we want to find out the 3 digit. So here, obviously, there could be more than 3 digits, and each digit could be duplicate. There could be a duplicate digit. So what's your approach here?
I just have a load of. I just look for the even numbers.
Even number. Sorry.
I just look for the even numbers. So 2, 1, 3, 0. There's 2, 0, 0 as the even number.
But how do you know it's an even number?
We check.
We divide by 2. I just know it.
Bruteforce.
How?
We check every numbers. We check every possible 3-digit numbers.
Check every 3-digit number. Right?
And then check if they check for the even numbers.
What do you mean by check every 3-digit number? So what do you mean here?
Make all the 3-digit numbers you can make.
From here, right?
Yeah.
That's one way. What's the most easier way to do that? You are quite close to that.
So
Check every, no, sorting is the last step. Check every 3-digit number. Okay, I'm going to read it several times until you figure out. Every 3-digit number. Every 3-digit number. Every 3-digit number. How many 3-digit number? How many 3-digit number?
The Bruteforce.
Yeah.
Maths.
How do we prove false?
maths.
Yeah, it's math, but okay. So can you give me a few 3-digit numbers?
642.
Okay.
999.
Yeah, no.
102.
102.
463.
Okay, so how many 3-digit numbers?
899.
How do you get it?
Because 999 and 100. 999 and 100.
I'm gonna read it again. Check every 3-digit number.
And then just do 100101 and do it.
Check every 3-digit number. There are 2 ways, right? One way is that Bruteforce, there are n digit here. I pick 3 digit out of it. Do this permutation, right? Permutation, Pn3. Permutation with a sequence, right? 1, 2, 3.
If there's like a duplicate, you can have 210.
That's
but
right.
can you do 210 again because there are 2 zeros?
Good point. Yes, you're mentioning a very good point. No, just this is unique, right? But it has to be sorted. There are 2 ways. One way is we type in into the input to do this permutation. N digit, picking 3 digit, do the permutation. We know how to permutate, right? We can use the depth search, backward search, or we can use the iter tool, function iter tool. we mentioned that iter2 stop permutation, right? Permutation, that will give us the actual permutation. Once we have a permutation, then we just have to check if it does not have a leading zero and if it's an even number. If it's an even number, we add it to the answer and we sort it. That's one way. The other way is there are limited number of 3-digit numbers. So we just go through this from 100 to 9999, step 2. And once we have, for example, like 100, we just check this 100 if it can be made from this input. Makes sense? So here we just have to check how many even numbers. 999 minus 100, right? Divided by 2. Roughly this number, right? For possibly plus 1.
899
Yeah, am I right?
899 divided by 2.
Okay, so just at a glance, which one is more efficient? Which method is more efficient?
The one over there.
This one is okay. Why?
I say so.
Any thoughts? Yes, this one is more efficient. Why?
Because it's limited, so
Yeah, it's limited. And then when we're checking if the
because it's so easy.
two approach, right?
Yeah.
The full permutation, yeah. Okay, so I'm going to write it, okay, and then you tell me the complexity, okay. Define a
Death.
5 3-digit.
Use red or green.
Okay, so this is the array of digits. Okay, so digit. We want to count how many digits per digit, right? How many frequency, the frequency per digit. So we use the counter, right? Okay. So C equals counter. Right? Can you tell me what this counter means? Counter digit.
It's a dictionary.
Yeah, dictionary. The keys will be digit. The value will
We
be
write it down.
the value will be how many times they appear, right? Okay, so now look. For I in range, we start from 100, right? This is the smallest, the mean 3 digit. The last digit will be 999, and we step 2, right? Actually, we step 2, right? Okay? So 100, 102, 104. This is what it means, okay? Step 2. Okay, now this I, what do we do? So, like 3 digit, like 3, 2, 1. How do we get this number? How do we get this number? How do we get this number? I equals 3, 2, 1. How do we get 1? How do we get 2? How do we get 3? 321, do something to modulus. Okay, so this one is 321 modulus
10.
10, yes, what? 10, right. Modulus 10, that would be equal 1. Okay, so how about this one?
100.
Is it modulus? 321 divided by 100. That gives us 3, okay, integer bar, okay. And how about this one? 2, how do we get it? How about we get rid of 1 first? How do we get rid of 1?
Shift.
But this is not binary, this is the base 10.
Oh.
But good point. Yeah, we can shift it in base 10.
You mean in Dean's?
Is it divided by 10?
Divided by 10. Okay, so we divided by 10 here. And how do we get these 2?
We subtract 30.
It's there. It's there.
Modulus
Modulus what?
10.
Yeah. We are looking for the 10, 100. This is because the number system we're using is base 10, right? Am I right? It's base 10, or decimal, right? This is what we call it decimal. This is base 10. Binary, base 2. Okay? And we also talk about base 16. What's that? Hexadecimal, okay? What's this mean? Base 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what's next?
1.
Base 10, base 16. A, B, C, D, E, F. Okay? Base 16. Okay, so for example, FF, what's this number in base 16? Look, F is 15, right? 10, 11, 12, 13, 14, 15. 15 and 15, so what's this?
30.
This is base 16. 16 times 16 plus 15. So what's this number?
Why 16?
Base 16. Okay, 123. How do we get this number in base 10? 1 times 10 to the power of 2 plus 2 times 10 to the power of 1 plus 3 times 10 to the power of 0. So it's 123. Okay, so here 15 times 6 base 16, right? Base 16 to the power of 1
Is it
plus.
255?
You get that from here? Wow, we're down. 255. Yes. Because why? This is equals to 100, but in base 16 minus 1, right? Base 16. Am I right? Because look, if I add 1 here, you carry over, right? F becomes 0. F plus 1 becomes 0. Carry over 100. 100, what's this in base 16? 1 times 16 to the power of 2. 256 minus 1, 255. Okay? These are all connected, right? Okay, so we go through these numbers, right? What are the 3 things? So if this 3-digit number is A, B, C, okay? Look, this is digit. I put a horizontal line above it. It means that A, B, C. This is A times 100 plus B times 10 plus C, okay? A, B, C. I put a horizontal line above it. It means that. So A equals I divided by 100, right? B equals I divided by 10 modulus 10, right? C equals I modulus 10, right? We got the 3-digit ABC, alright? And then now we want to find out if these 3 digits can be made from the digit, right? So we use the counter. We can do this. If counter A, B, C is smaller or equal than this C, right? Look, this is very important. Look, if this counter, if the 3-digit the frequency is smaller or equal than this C, then we answer here, okay? Answer array. Answer dot append I, right? And then return answer. Okay, so can you tell me why we don't need to sort the array here? Sort the numbers.
Because we're going 100 to 90.
Well done. Okay, you're listening. Yes. Okay. The second question is why we don't check if it's an even number here?
It says 2.
2. Yes, step 2. So it's 100, 102, 104. It skips the odd number, right? Okay. So that's very good. The time complexity. If we ignore this one, right? If we ignore this one, if we don't consider this one, what's the time complexity? O1, yeah. O1 because this is a constant loop, right? And then the constant loop, this is constant. This one, we treat it as constant, right? Because comparing this is the limited, right? And this is given as, we just don't consider that. But if we consider this one, this is not O1 anymore because the digit could be n, right? There could be n digit. Now we need to go through this n digit.
Yeah.
Another way, as I was saying,
Bruteforce.
yes, this is going through this, checking this backward, right? And then if we given this number, digit, so we actually need to permutate, right? Permutate, if there are n digits, permutate 3 digits out of n, right? What's CN3? CN3, picking 3 apples out of n apples without orders. This is with order. So this is equal CN3 times P33, okay? So how do we permutate? We can depth search, breadth search, but I leave it to the next few lessons. But another way is to use the function tool. From iter tool, import permutation, right? Permutation. 1, 2. There are 2 apples. How many ways do we permutate it?
1, 2, 1, 2, 1.
1, 2, 3. How many ways do we permutate it?
1, 2, 3, 6.
Yeah, this is full permutation, right? 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1, right? N apples. The first one has n choice. Second one has n minus 1 choice. The third one has n minus 2 choice. The last one has 1 choice. What's this? N times n minus 1 times n minus 2. 3 times 2, 1, 1. What's this?
Combination.
Factorial. Okay. So we use this function, right? From iter to the import permutation, right? And then we can do this. For A, B, C, permutate 3 digits, right? The hundreds, the tens, the ones. In permutation digit, right? I want to pick 3 digits out of the digits A, B, C, 3 digits. And then I just have to check, look, if A is not equal to 0, right? We don't have a leading 0 here, right? And if C and 1 is 0, so this means that if it's an even number, answer, because it could have contain the duplicate, so answer, we need to put it as a set. So answer dot add what? A times 100 plus B times 10 plus C, right? And then return sorted. We sorted the answer, okay? What's the time complexity? Permutation here, it's here, look. The permutation here is Pn3. This is the time complexity, right? Because permutation returns this number of permutation. Space complexity, again, right? Because each number could be an even number, right? 2, 4, 6. Then how many possibilities? 2, 4, 6. If the given numbers are 2, 4, 6, how many?
6.
6, yeah, because look, you can do any permutation and it's 6. So in the worst case, the space complexity is this, the time complexity is this, okay? And also, don't forget, we have to sort it. The time complexity is Pn3 plus sorting. If there are n element, we want to sort it. What's the time complexity? Okay, log n, right?
Okay.
Yeah, so On is this one, right? So it's Pn3, this is n, times log Pn3, okay? So this is the time complexity, okay? Yeah? Okay, so what have you learned today?
About finding 3 digits.
Finding the 3-digit even number.
We are given a list of digits. We want to find out all the 3-digit even numbers. No leading zeros. The result has to be in increasing order, sorted, right? And how many ways we can do it?
2.
Okay, you talk about one.
Permutation.
Yeah, we can do this permutation, just brute forcing. Actually, permutation is the brute force from the digit, right? And then we check this, no leading zeros, and it's even number, then we add it. And
Sort.
The next one is so we count. So we start from 100 and then end to 998. But we skip the odd numbers, so it's already sorted as we're going up. So we go 100, 102 up to 998.
and then we find out the ABC 3-digit, and then we check if these 3 digits can be made from the original digit. Then we use the counter, right? We can directly compare two counter to see if a counter is included in another counter, right? Smaller or equal than C. If it's a smaller or equal than C, it means that the original digit, we can use the original digit to make this I digit, okay? And this I 3-digit ABC. Okay, that's it for today. Bye bye.
Bye.
Bye bye.